Our group, our initial working group, Forwarding Abstractions Working Group, was formed in anticipation of the challenges that we've been seeing for the last couple of years. And we actually published a spec last year, and we're starting to see some adoption. So I'm gonna talk you through kind of how this works, and of course, you can tell by the packed room that a lot of people regard interoperability as the most interesting subject right after lunch. All right, so which one of these buttons? It doesn't seem like, there we go. So first, a little picture of the sequence. I'll talk about packet pipelines. All of our packet forwarding engines have effectively pipelines. We don't normally think about them, but the fact that there's such a diversity of pipelines and we want to control them differently is what makes the OpenFlow interoperability such a challenge. And so then we'll talk about how we are introducing a framework. It's not required at this point, but it may be that over time we enhance it to such a degree that it ends up being de facto required. And then the spec that we produced is called Table Type Patterns. There's some history behind the name, but essentially TTPs are pipeline models that allow for the controller and the switch, as Mark mentioned, to work out an agreement. Sorry about my voice. I'm getting over the cold, so it just sounds bad. It feels fine. I apologize. There is now adoption of TTPs going forward in a couple of different ways, and there's some a little bit of evolution that's going to make this move even better. So early OpenFlow, if you think about OpenFlow 1.0, it had a notion of a pipeline, but we never talked about it. It was such a trivial pipeline. It was a single stage. It was a very big stage. What we often called a TCAM, where you could match all kinds of different things and provide any number of actions, all these exotic actions, but you could only do that once. One match, one action, Complex match, complex action, but just once. Most pipelines are really much deeper than that, and that shortcoming of the limited pipeline was recognized very early on, even before the ONF. So OpenFlow 1.1 introduced multiple tables. As many as 255 are allowed, which is very much overkill. One table, one stage is much less than real-world pipelines, and 255 is much more than real-world pipelines that are typically in the 5, 10, 20 kind of a range. So as I say, the shortcoming was recognized. OpenFlow 1.1 introduced more tables, and this was actually, OpenFlow 1.1 actually came out the week before the ONF was founded, and there was a bunch of stuff, you might say, in the pipe that was being developed, and they said, oh, we better get this published or it'll get lost in the transition, and there was probably some accuracy of that. But one of the things that happened was, before the ONF, there had been a tradition of working code. So going back to 2008, the early stages of OpenFlow, they would create some working code and then spec that and create more working code. With 1.1, they didn't have time. So they published 1.1 and boom, we were in the ONF, and they didn't write working code. So some of the challenges about having multiple tables were not really addressed. Essentially, 1.1 enabled much more complex packet pipelines, but they didn't really solve the problem of, well, what about this diversity of ASIC pipelines? So if we think about pipelines, and people like me do, sorry about that if you don't, but it is important to understand what's involved and why this is hard, and not just people goofing off and that failed to really nail the interoperability thing. So here are just two different pictures of pipelines. They're both interesting pipelines, but for different use cases. As it happens, these pipelines are abstract or sort of virtual pipelines. It's not that necessarily a physical pipeline matches either of these two things. In fact, these pictures both come from a Broadcom document that is about the same chip. And in fact, the chip has an underlying pipeline that's more complex than either of these, but they can represent either of those pipelines. This is very interesting because many of our use cases, maybe it's tunneling or MPLS or simple routing and switching, they all can be represented with a pipeline that's not too complex. And we don't want to be trying to think about a complex pipeline if we don't need to. What's interesting about these are represented in OpenFlow terms. So the pink boxes are flow tables that you can access using OpenFlow messages. And then the gray tables are group entries that are also part of OpenFlow 1.3. So these are mechanisms for representing a pipeline in OpenFlow controllable terms. That's quite powerful. This OFDPA that Broadcom produced, that's OpenFlow Data Plane Abstraction, I believe, is what it represents. It exposes tremendous amount of horsepower that's available inside Broadcom chips, and it makes them controllable, makes these chips controllable through OpenFlow, if you have the right software drivers and stuff. But without this document that describes how to control the Broadcom device, it would be impossible for a developer to figure out, what is it I'm supposed to do? What messages should I send in order to get the chip to do what I'm sure it can do? I've seen the specs, I've seen the data sheets, but what message do I send? Now that we have these documents, and this is essentially a PowerPoint version. These are PowerPoint versions of a TTP in a sense. So as I said before, table type pattern is beware, or don't worry, sorry, no quiz at the end. You don't have to memorize these pipelines or flowcharts. But these are a PowerPoint representation. TTP is a textual representation, which you'll see a glance of later. So essentially what we had before was a framework gap. We had a need for some agreement about what the pipeline was, but we really didn't have an agreement. In OpenFlow 1.0, we did have an agreement because it was just a single stage. It was easy to agree on that single stage. Every chip of any interest could support that single stage. But when we moved on to multiple stages, it got much more complex. If you're using an NPU, a network processing unit, that's basically soft, then you could support the anything goes model. But most deployed boxes are based on ASICs, and ASICs are a little bit cheaper, a little bit cooler to operate, generally have higher, less latency and better throughput than NPUs. I mean, so there's trade-offs. Less flexible, but you get some other benefits. And so ASICs are in most of our network boxes. And so if we want to use SDN on most of our network boxes, then we have to figure out that pipeline problem. So the founders of my working group, that's myself, but also a number of other folks as well, saw this coming. When we saw multiple tables and we looked at how OpenFlow was based, we said, hey, we're going to need a framework that sorts this out. We need to have pipeline agreement. So this is where we come up with our pipeline-based framework. We conceived of table type patterns. It is a pipeline model in OpenFlow terms, as I mentioned before. Each individual TTP, that is each individual model, is an abstract pipeline based on either the application needs, or it's an abstract pipe or a nearly physical pipeline based on a device family, like the Broadcom one. So the Broadcom TTP, OFDPA, is more of a device-oriented one. Actually, an earlier version it was trying to split the difference and be partly application-oriented, but their version 2 is very clearly a Broadcom spec. The TTP spec that my working group produced, the ONF produced, came out in June of last year. Even before that, Broadcom came out with their early version, and shortly after that, oh, I'm getting ahead of myself, that's the next slide. TTPs are text files, I mentioned that before. We aim to support a number of formats. We're not particular too much about the format. It's a simple data structure kind of model. File types that support that are like JSON, XML, and other similar formats like YAML. I think Yang can also describe a TTP. So here's a picture in the gray, blue-gray, is the text version, simple text version. In that case, it's JSON, which is JavaScript object notation. I'm sure you either knew that already or you didn't care, probably. And the other is a more of a form editor model where we use a schema, and there's big advantages to this. It takes a bit longer to produce the form editor, but for somebody who's trying to create a pipeline model, you don't have to remember every keyword and so on. You can just click those drop lists and so on and pick out the terms that you want. So we're making progress on the tools and making it simpler to develop these pipeline models, these TTPs. There we go. Here is the early version of the framework that we had. The idea was Well, we're going to have these application rules. They're kind of, they specify the use case rules. What is it that a code developer wants from his switch hardware? And we describe that in that abstract pipeline, in those abstract pipeline terms. So TTP A, B, and C represent those application needs. And our early plan was that the switches would create drivers to support those application needs, to support a collection of use cases with similar needs, so it might just be a simple router, as I said before, or an MPLS device, or something that supports tunneling, maybe VXLAN, maybe NVGRE. You could have one that's NVGRE, one that's VXLAN, and maybe another one that can do both. And so here we show the devices. Just as Broadcom can support many use cases, some devices may support many use cases, and some devices, like device T over on the right, might only support one. So this was our early model. It had some challenges associated with it. Switches are not great coding environments. Typically the software is updated a couple times a year, so it's not really a great agile model either. And we were in a situation where essentially the device vendors had to kind of, I didn't really say that, we expect that there would be a number of the use case models produced by the ecosystem. So the ONF can participate in that, but vendors can as well. So you might see A, B, C, but also D, E, and F that are not shown here. And so the device vendor, the switch vendor, would have to choose among the up and coming TTPs and figure out which ones to write drivers for. Oh, and then they have to, suppose those models go through a few iterations before they settle down. Oh, now you've got a maintenance problem. So this was a little bit challenging. Nevertheless, Broadcom saw the power of this. They were active in our working group, still are, and they brought out version 1 even before the spec was published, and then version 2 in December of last year. And they produced the JSON, which is the text file representation, using some software tools. That's kind of interesting because originally we had sort of aimed the TTP format to be kind of human friendly, not the most software, hardware friendly or machine friendly. Similar time frame, Open Daylight also started supporting TTPs because, in fact, the chair of the TSE, he's also now at Brocade, but he was at IBM and active in the working group in the early days. He saw this problem too. He understood we need to figure out how to get the interoperability so that we can, I basically want to control my switches, and I don't care who they get them from, but I know they have different pipelines. How am I going to do that? So he's serious about adding this interoperability capability to Open Daylight, and together we're on a project team, the TTP project team at Open Daylight. And in addition, there's an ONOS-based version of Atrium, which you'll hear about here at this conference as well. Atrium is an effort by the ONF to produce a sort of a reference platform that can deliver useful, market-recognized useful functionality based on open source components. And the Atrium ONOS combo also uses a TTP architecture. So we basically were homing in on something that makes a lot of sense to a lot of different people. But the other thing that's happened is all these activities have given us good feedback, and we're ready to enhance the TTP picture. So instead of putting such a burden on the devices and expecting the device vendors to constantly be guessing and anticipating what are the winning use cases and the use case models, the pipeline models, and having to support those in their box. Instead, it moves toward the Broadcom model, which is a much more realistic model for a device vendor. The device vendor creates a TTP that represents their device, and they may have 2 or 3 TTPs that represent their device, depending on maybe market segment or something. But they can focus on that. They don't have to worry about the changing winds or whatever of the marketplace, and we can put support for that device-oriented TTP, that is a device-oriented pipeline model in the controller. That's what these red boxes represent. Now, essentially, that is really more of an interface definition. That's what that model is. It's like these are the OpenFlow messages that work for this pipeline. And so there is a notion of some code that goes between the application needs and the device pipeline. It's not depicted ideally there. I haven't quite figured out what ideal would look like, but I'm working on that. What we need, though, is to map from those what the application needs onto those pipelines, and we're in the process of doing that with software that is part of Open Daylight right now. And essentially, this is fairly straightforward. Now that we've figured out how to represent what a application needs, we can represent that as a TTP. What a device can do, we can represent that as a TTP, and essentially we can now compare those. And that comparison is just beginning. We expect to have some basic versions of this in the next release of Open Daylight, which is the Beryllium release due out early next year. This will allow for a mapping mechanism. The tool will help with mapping. This mapping function is something that we've been doing as humans for a long time. There are many use cases for those Broadcom switches, for example. Those Broadcom switches have been supporting many use cases with this complex pipeline, and they've been doing it using the Broadcom SDK and other applications and so on. So this is a function that's not exactly new to the industry, but trying to do it in a common way across a number of devices and across a number of applications is what we've been looking for. And basically, as I said, we're seeing really strong convergence on this in a number of different parties. So the ONOS Atrium implementation, the Open Daylight work, Broadcom's investment, and other people are coming forward with TTPs as well. So this is how we're driving forward in the interoperability in OpenFlow. In addition, so we've gotten this feedback, and we've recognized that our 1.0 version of the TTP spec it didn't have everything we need. It had, in some cases, a little bit more than we needed, and so what we're looking to do is to simplify it a little bit for software consumption, which makes it easier to write tools. We were more concerned about the humans, but it turns out humans will typically interact with TTPs using tools. So in which case, well, we should be making the tools easier, and that'll help us drive forward on a lot of different software, including the editors and so on. And one way you do that is you write schemas that describe the syntax. Our syntax was a little bit too flexible, which makes schemas difficult. So we're going to structure it a little bit more and simplify the schemas. And we're going to come forward with some more examples of TTPs and a little bit of tooling as well. There's an app fest. There was an app fest already this past May. It was focused on getting applications to run on a variety of devices. We're now going to introduce TTPs into that app fest as well, with the idea of exploring TTPs as a potential mechanism for conformance testing. So conformance testing is certainly a part of interoperability. OpenFlow 1.3, which was specified 3 years ago, we only really are getting started on conformance testing. Earlier this year, the ONF published a 1.3 conformance test, but it was only a basic test. It leaves out a number of complex details like multiple tables and optional features. To really take advantage of OpenFlow, we want multiple tables and we want optional features, and so we need to go beyond the basic conformance test, and we believe actually several folks, the test folks, the Open Datapath working group, my working group, and there's another group called the Chip Makers Advisory Board, which I'm also a member of. They kind of believe in this model as well, that we create a number of pipeline models for use as conformance tests. So in this upcoming App Fest in the spring, we will be working to do a sort of preliminary, what would it look like if we used a TTP as a basis for a conformance test. And I think that's it, yeah. So that's where we are. We've built up this model. We're starting to get some traction. We're trying it out. There's code running and using these TTPs, we can see in a number of ways how there's value, and also we can also see additional work that we need to do. And at this point, how am I doing on time? Oh, lots of time. So we have time for some questions. And I've been told that whenever you ask this question, you have to give people like 10 seconds to think of their question. So we'll pause while people think of questions. Is the individual who asked the question about OpenFlow interoperability earlier in the day, is that person here? You know who you are. I wasn't here, so I don't know who you are.
No questions for Curt?
We should put Fabian on the spot. Oh, there we are. we have a microphone?
Hello, my name is Evan. I'm an network staff. So my question is more about what's about the dependencies between the OFDPA and the TTP itself. Is it something like the OFDPA is the first stage for TTPs, or Broadcom will support it later, maybe?
So I'm not sure I completely heard the question about the difference between TTP and OFDPA. Okay, so actually, that's a great question. On OFDPA, the OFDPA is an example of a TTP. It's an example of the red version of a TTP. It's very oriented not toward a single device, actually, which I probably suggested, but toward a family of devices. It can support a number of Broadcom, I think even a number of Broadcom device families, which is pretty remarkable. That TTP, the OFDPA, is useful in a couple of ways. The PowerPoint is useful to humans, and all the documentation helps you figure out how you could manipulate the device by writing an application to support that device. And then the JSON, the more machine-friendly version, is also very useful, so we can do that automated mapping. So we'll have simple models. So the pictures I showed earlier were more, let me get them up here. Here are relatively simple compared to the Broadcom chip itself, which I think has about 25 tables or something like that. In order to support, these are only 2 pictures of perhaps 10 in the data sheet, and it supports all 10 of those models, and many of the tables overlap. So it doesn't necessarily make sense that you would be doing both of these at the same time. In some cases, you may be able to combine them. But anyway, the TTP is useful for the human coder and also useful for that automated mapping scheme where we could map something like this without the data sheet, map a pipeline, an abstract pipeline like this onto a kind of a physical pipeline that is in the sort of the text sense of the OFDPA TTP. Did that answer the question?
Yes.
Okay, good. Thanks for the question. It was actually a very helpful question. Another one in the back. Here.
How this will work in the initial configuration of the system? So is there any kind of exchange of
Another excellent question. So indeed there is. So we've defined a couple of different ways of handling that configuration. There's an informal way. That's not one of the defined ways. The informal way is that by hand you go and tell the controller, and then you tell the device. So that is useful for laboratory work in our early days, and that's kind of what we're using right now. There's another version of what we call negotiation. So let me move on to this simple picture where the device has more than one TTP. In this model, we have a defined negotiation mechanism. It's based on OpenFlow config protocol, where they exchange messages and discover which TTPs are available in the device. And the application should know which the application may support more than one TTP, and so there's a potential algorithm for choosing the preferred TTP, or you could just find the first one that matches. I suspect there would be preferred ones. In addition, we've developed and specified an extension to the OF switch protocol because OF config is not broadly adopted at this point, and it's less. The negotiation capabilities are not as complex, but it can request a particular TTP. So essentially the model is that they can find out what each other supports and agree on that. And there's each TTP, there's unique naming mechanism for TTPs. There's versioning mechanisms for TTPs as well, because we anticipate that they'll go through a versioning exercise. Some of the things we're adding in the next version of TTPs is an improved ability to do code reuse, so that essentially we can develop libraries of TTPs, because we expect that there will be simpler use cases that have simple application needs, and then over time those will grow and they should be able to reuse the ideas from early TTPs, or essentially early pipeline models, and build on those over time. So you don't have to build from scratch all the time. All right, any other questions? Thanks very much, and thanks for coming in after lunch and listening to the fascinating story of OpenFlow interoperability. We should probably move forward to the transition slide. There we go. Is there anything up after this?
Yes, it's the camera.
Oh, okay. Thanks again.